Welcome to today's Explainer. We hear a whole lot of hype about AI these days, but today we're actually going to look under the hood of a real deployed automated job application system. And more importantly, we're going to explore how this resilient machine survives the inevitable failures, roadblocks, and massive friction of the modern web. So let's just dive right into it. What exactly happens when a software agent tries to apply for jobs completely on its own, but it hits rate limits, bot walls, or just totally broken web forms? Because, as anyone who builds software knows, out there on the real internet, the so-called happy path almost never happens. In fact, this entire architecture is rooted in one core philosophy from our source material. Every single step here exists because it went wrong at some point. This system wasn't just built for success. It was engineered specifically to handle failure gracefully and just keep pushing forward. Here is our roadmap for the explainer today. 1. Meet the 3 agents. 2. The 7 filtering gates. 3. Inside a single application. 4. The AI model cascade. And finally, 5. Tracking success and failure. All right, part 1. Let's meet the 3 agents, the system's core actors. Picture this setup. Agent 1 and Agent 2 actually share a single Microsoft Edge browser session on port 9223. Now, if Agent 2 doesn't politely wait for Agent 1 to finish its task, they'll essentially fight over the steering wheel and crash the entire browser right in the middle of an application. Meanwhile, you've got Agent 3 running fully in the background, quietly drafting cold emails without needing a browser at all. Now, Agent 1 is pretty smart about how it works. It rotates through major platforms, places like Wellfound, Indeed, and LinkedIn in batches of 10. And to avoid draining a single source or tripping any spam filters, it dynamically spaces out its applications anywhere from 3 to 150 seconds. This part is absolutely brilliant. The system has a really clever workaround for Naukri, which is a platform guarded by a super strict Akamai bot wall. Instead of forging a request that would instantly get blocked, the agent just acts exactly like a normal user. It navigates to the standard search page, lets the page execute its own JavaScript, and then simply reads the response directly off the network wire. It is such an elegant solution to a really tough roadblock. Moving on to part 2, the 7 filtering gates, where the system aggressively rejects the bad fits. These initial gates, they cost absolutely 0 AI tokens. The system just quickly discards roles that are duplicates, roles demanding a senior or principal title, or postings that ask for the wrong primary technology stack, like .NET or C++. It is all about preserving precious resources for the right opportunities. Then we get to Gate 6, which requires a fit score of at least 50. But here's the kicker. Because this is a purely deterministic check, meaning it uses strict, hard-coded rules to match skills against text rather than relying on unpredictable language models, it costs nothing. The system can keep filtering jobs even if its expensive daily AI budget is completely tapped out. And if you're wondering exactly why these rigid rules exist, just imagine this number, 3. That's the number of applications to United Health that accidentally went out in a span of just 4 minutes. That little mishap is exactly why the strict 1 application per company per day limit had to be engineered into Gate 2. That brings us to part 3, inside a single application and navigating the friction. These 5 steps are what ensure forward momentum. It starts by safely uploading the resume and patiently waiting for the site's own parser, being very careful never to overwrite what the parser extracts. It fills in empty fields, answers the questions, and crucially, it checks for a bot wall on every single frame, not just the main page, before finally hitting submit and verifying the success. And the real-world friction here is just immense. For example, a generic submit path once blindly fired off an application where a required "what interests you about this company" field was left completely blank. The specific handler refused to do it, but the generic path pushed it through anyway. So this proves exactly why strict step-by-step verification rules had to be added to the mix. Okay, part 4, the AI model cascade, or how the system manages its most expensive resources. So, how does it actually answer those tricky custom text boxes? Well, the system relies on tiered logic. First, it uses simple hard-coded rules. If that doesn't work, it checks a JSON cache of previous answers. It only calls an expensive AI model as a total last resort. It's all about efficiency. Cheap rules handle basic facts like notice periods or years of experience. The expensive AI model is saved strictly for genuinely open prose that requires critical thinking. Specifically, it's used for prose that avoids mentioning a specific company name so that the shiny new answer can be cached and reused later. And this system is built to survive outages. It refuses to die. When the primary Grok model exhausts its 100,000 daily tokens, it gracefully fails over to Google Gemini's free tier. If Gemini hits its quota, no problem. It falls back to a local instance of Llama. It simply refuses to stop working. What I find really fascinating is how it handles the inevitable API timeouts. It literally reads the error message and rests for the exact time the provider requests. It used to just guess a flat 2 minutes, which ended up burning quota that was already gone. It even autocorrects AI hallucinations, like when a model stubbornly wraps its answer in unnecessary markdown code fences. Finally, part 5, tracking success and failure in closing the loop. Failed and unknown are not the same thing. This quote completely reframes how we look at the data. Treating unknown states as failures is what once caused the system to miscategorize 16 successful applications. Precision in data tracking turns out to be just as vital as the application process itself. You've got to deliberately separate these end states. A failed form means a button is missing or a wizard is stuck. But a needs a human state? That's usually a CAPTCHA or a login wall. If it hits that wall, the machine smartly stops what it's doing and waits for you to step in and help. To ensure accuracy, the system even cleans up its own mess. It automatically corrects its own database by reading incoming Gmail receipts in the background. If an employer confirms an application, the system automatically moves that job from awaiting review to the applied column. That's a repair task that previously had to be done entirely by hand. As we wrap up this explainer, seeing this incredibly resilient machine in action forces us to step back and ask a much bigger question. Is engineering our way around rate limits and bot walls actually streamlining our future? Or are we just adding another sophisticated layer of automation to a hiring system that is already fundamentally broken? It's definitely something to chew on the next time you hit submit. Thanks so much for joining me on this explainer.